Today we're going to talk about advances in X-ray for demanding applications. And my main focus is on the applications demanding for the X-ray systems. We all have many and varied demanding parts of the work that we do, whether it's the environment that the products are going into, the length of time that they have to work for, the speed that they have to work, even demanding down to the lines and spaces on the bare printed circuit board. But most of the time today, we're going to look at the things that are putting more and more demands onto the X-ray systems that we have. We're going to look first at voiding. Voiding has been a key subject for a very long time. With the move to lead-free, it became even more important because, as a very clever friend of mine explained it, when Europe moved to lead-free, the Romans started soldering. So we have quite a lot of experience in soldering using lead. And today we start without lead. So you have some idea of the amount of knowledge and experience that there was in a soldering system containing lead, and the amount of knowledge that we had with tin, silver, copper, and all of the other things that were new. The first thing that we noticed when we changed was the amount of voiding increased, and everybody started to be suddenly heavily paranoid about levels of voiding and void measurement and all of the other things. Then, of course, we got bottom terminated components like QFNs, which have a central pad area, and that pad area is used to move temperature. And of course, if there's a void, you don't you have air. Air is a very bad conductor of heat, whereas solder is a very good conductor. So to put it simplistically, if you have 40% voiding on that center pad, you reduce the amount of heat that you transfer by 40%. A few weeks ago, I was talking to a designer of circuit boards where we had a problem with small components that had a central pad failing in service. And I asked the gentleman, what kind of tolerance did you put in for voiding in the heat transfer of the central pad? And he just looked at me and said, pardon? So I drew a few little sketches and explained to him the process of assembling the board and how you were never going to get 100% void free in that central pad. And he said, oh my God, I never realized this. I just worked with the numbers off the data sheet and didn't put in any margin for error or voiding. So yes, voiding becomes more and more of an issue. X-ray tubes, obviously where it all starts. Digital detectors, we've had a lot of movements in those in the last few years, enhancing the image that the operator sees on the screen, and also 3D computer tomography, reconstruction, all of those things. So we have a wide and varied agenda, but my first slide is really just to make the engineers out there, like myself, a little bit nervous. I don't know if any or many of you are working with the unit that I will call 0.3 by 0.5 by 0.15 millimeters, or 01005 as the American systems will know them. Recently, I came across this component, and it did not have any fillets. So I kind of looked at it as you do the first time you see something new, and spoke to the guys, and then looked very closely, and there was no end termination on the component. It effectively was, as you can see from the picture on the right, a bottom terminated component. The comment, again, when I checked from the manufacturers, is that this is now saving us space because, of course, we don't have to put down a pad. So we have more space on the board, so we can squeeze more and more very small things in there. Anybody who's ever mounted a bottom terminated component knows that yeah, these things without fillets are not easy to get down. They're not easy to keep flat. And now we're doing it with the smallest possible component that is out there. So, gentlemen, any of you are very young engineers just starting out, good luck. As you know, with over 30 years experience, you can work out that I'm no longer a young engineer, and I won't have to worry about what's going to happen 2 generations after this wonderful little thing.